The opposite is less than. We use the open dot. Is less than or equal to. We use the closed dot. So once again, when we're graphing on a number line, we'll look at these two values. We're really looking at the less than. Anytime the line is underneath it, we'll be using that closed dot. So once again, this is used to compare two given values. The smaller value will be on the left and the bigger value will be on the right. Some examples: 8 is less than 14, -9 is less than -4, and x is less than 5. Just as a review, integer, the set of numbers consisting of the whole numbers and their opposites. There's an example of the integers, and here is some non-examples of integers, those decimal points and fractional parts. The whole numbers are the set of numbers starting at 0 and going up, increasing. There's your example, and here is your non-examples: pi, 6/11, 0.125, and -8. So the question again, finite or infinite? So let's read this together. What this says that x, or some number, is an element of the whole numbers. So what this is saying is that x is a whole number. So it's only those numbers. So example, x could be 0, it could be 1, it could be 2, it could be 13, it could be 479, it could be 1,073,421. It could be any of those numbers. It's a whole number. X is located between, as 0 is less than x, but x is also less than 10. So x is in between 0 and 10. Meaning that if I start with 0 here, and I have 10 over here, 5 will be in the middle, 6, 7, you get the idea, 4, 3, 2, 1. Let me just complete my number line here. If I'm going to plot this point on my number line, this symbol right here is telling me I'm going to have an open circle at 0 and 10, and x is actually all the whole numbers in between there. Can I count this set of numbers? Yes. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 elements large. Does it have a starting point and an ending point? Yes. The solution to this set would be the numbers 1, 2, ... all the way to 10. Does it have a starting point and an ending point? Yes. Therefore, it is a finite set of numbers. Let's take a look at another example. X is an element of the integers. So x is an integer now. So remember, an integer is defined as all the whole numbers and their opposites. And x is less than 5. So plotting this point here at 5, just put this on my number line. I'll add some other numbers. I'm thinking of all these numbers that are less than 5. My number line would also, of course, go in this direction. I'm not really interested in those numbers at this time. It's going to be an open, and it's all these that are less than it. I really don't know where to end, so I'm going to just draw an arrow there pointing off in that direction, meaning that this set of numbers is going to continue on in that direction forever. In fact, if I was going to write this set in number notation like this, in set notation, I'd have to start with a ... and I might put 3, 4, and 5, meaning that this would be the integers less than 5. Actually, 5 would not be included in this set because I want only integers that are less than 5. So it would be starting with 4, 3, 2, 1, -1, and so on. Is this set countable? No. Does it have a starting point? It starts at 4. Does it have an ending point? No, therefore it is infinite. Take a look at this example. X is an element of the rationals. X is greater than 1. I'll give you a moment to think about this and determine if it's finite or infinite and why. Okay, coming back. Rationals is a very large set of numbers. Remember, the reals are broken into either the rationals or the irrationals. So I'm looking at all these numbers that are greater than 1. This is all those fractional parts, but also 2, 3, 4, 5. They're all greater than 1. Anything greater than 1 is definitely going to be an infinite set of numbers. The real numbers. X is an element of the real numbers, or belongs to the real numbers, meaning that it's all those fractional parts between 1 and 2, but it also includes 1 and 2, because 1 is less than or equal to x, but x is also less than or equal to 2. So if I'm on my number line, and I have 1 and 2, x is going to be everything in between these numbers. This symbol is telling me it's going to be a closed dot. So as I shade my dots, and it's going to be all these numbers in between. Intuitively, I feel like there's a starting and an ending point here, but there's not. The amount of real numbers between 1 and 2 is actually an infinite set of numbers. If you were to tell me a number that's between 1 and 2, I could come up with a number greater than that number. So even if you said, well, 0.9, or 1.9, excuse me, I might say, well, how about 1.99? And then you might say, well, 1.999. I might just say 1.9999. And we could go on and on and on. This number of nines would go on infinitely. You can see just this amount of numbers could go this direction and that direction very quickly. Just doing the 1.9 pattern over and over and over. Reals will most definitely be infinite. The irrationals. X is an irrational number greater than 0. If it's greater than 0 and it's an irrational, how many of those crazy square roots can you think of that are greater than 0? How about the square root of 2, square root of 3, square root of 5, square root of 6? Pi is going to be in there. The square root of 101. That's going to continue on and on. So even though it might have a starting point, it definitely is going to continue on. So that set would be infinite. One more example here for you. X is an element of the natural numbers. X is less than or equal to 10. Give you a few seconds to think about this one. So the natural numbers, remember, start at 1, 2, 3, 4, 5, and continue on. So if I'm thinking about less than or equal to 10, 10 is going to be included in that set, but I have a starting point at 1 and an ending point at 10. It will be a finite set of numbers. So I would like for you at this time to write down if the situation provided is infinite or finite, and I will check that in about 30 seconds. You may want to pause the slideshow at this time. Coming back right now. The set of whole numbers greater than 5, infinite or finite, that set of numbers is most definitely going to be infinite. If I think about the whole numbers greater than 5, I just begin counting 6, 7, 8, 9, and to infinity. The set of integers between -1 and 4, I can write those down. That would be 0, 1, 2, and 3. I can count that set, therefore it would be finite. Rational numbers less than 0. Rational numbers, all those fractional parts, all those integers, and then all those numbers, definitely going to be infinite. The odd whole numbers between 0 and 6. Odd whole numbers, so that would be 1, 3, and 5. There's my set of numbers. Countable, most definitely. Therefore, it is finite. And odd square roots, I can continue that infinitely. That concludes our lesson for today. Please make sure you complete the homework assignment that is in our module. Thank you.